Okay, we are looking today at division, and this time we are going to be dividing decimals by decimals, and that's something that we haven't worked a whole lot with so far. But let me just show you an introduction. You see, we've got 6 divided by 2. We know that equals 3. Sometimes we could see it like this as a fraction. 6 divided by 2 equals 3. Now, let's say I change this a little bit and I multiply the 6 and the 2 by 10, making 6 times 10 is 60, 2 times 10 is 20. Now, we've made these numbers 10 times larger. Now it's 60 divided by 20, but my answer still equals 30. Here again, I took 6 halves. I made each number 100 times larger. And now I've got 600 divided by 200, and that still equals 3. The reason I'm still getting 3 every time is because I'm keeping the number in proportion. For instance, if I made this number 10 times greater, I made this number 10 times greater. If I made this number 100 times greater, I made this number 100 times greater. So when I divide, I'm still going to get the same answer because I kept the ratio the same. I kept them, I made one 10 times bigger and I made the other one 10 times bigger, and so on. So this is what we're looking at today. Today, we're going to look at, this is dividing a decimal by a decimal. This is my dividend, and this is my divisor. Remember, your dividend goes in the den, and your divisor goes at the door. And this is 9. Now, here's what I did. I'll cover all this so it doesn't look all confusing right now. I said 2 7/10 divided by 3/10. I made each number 10 times bigger. When I made it 10 times bigger, and by the way, the reason I chose to make them 10 times bigger is this is my my divisor. This is going to be my divisor at the door. This number right here is in control. It runs the show. If I want this to be a whole number, so to make that a whole number, my decimal must move one jump. And if I moved one jump, that means this number has to be multiplied by 10. So when I move this one, multiply this one by 10, and move the decimal to the right one time, I get 3. Whatever I do to one, I have to do to the other, the same thing. This one, I multiplied it by 10 also, and the decimal moved from here to here. So now it's 27 divided by 3, and I still get 9. Now, I decided, although I didn't have to try multiplying the numbers by 100. Although the only way, the largest, or the most I had to move was 1 because I wanted this to be a whole number. But I said, well, what if I multiplied them both by 100? So when I multiply this by 100, the decimal moves 2 places. So if it's here, then you go 1, 2, and that makes that 30. This one, it's here, go 1, 2, and that's 270. So 270 divided by 30 is still 9. So the reason I'm still continuing to get the same answer is because I'm keeping the numbers in proportion. Now, this can be divided. A decimal divided by a decimal can be divided, but it's not very friendly to work with. The reason I take these measures, these steps, is so that I can get these numbers friendlier to work with. As we go through the practice today, I think you'll understand that better. All right, we are in the Learn Books, and we're on page 307. So if you would, open up your Learn Book and Follow me there. Now, A and B are already done for us. So I'm going to skip those and let's just go on to C. Now notice they've got 3 and 5/10 divided by 5/10. Let me just go ahead and set up the division like we're used to seeing. Your first number always goes inside. This is what is getting shared. So I'm going to write 3 and 5/10 inside and 0.5 here. Now, this is my divisor. This is my divisor. And it's the boss. I need this divisor to be a whole number. There's a catchphrase that I say, you can't divide with a decimal outside. So if I want this to be a whole number, I want that decimal to jump from here to here. And I'm going to make it a little bit bigger right there. So I just moved the decimal one place to the right. To do that, that means I multiply this number by 10. If I multiply this number by 10, then I must multiply this number by 10. So this decimal must move one place to the right. And I'll bring it straight up. Now I'm dividing 5 into 35. 5 won't go into 3, but 5 will go into 35 7 times. 7 times 5 is 35. Subtract 0. My answer is 7. So this problem, 3 and 5/10 divided by 5/10, would also be 7. The reason we're moving the decimal, multiplying each number times 10, is to get this number in friendlier terms. If they had given us this problem like this, here's my dividend, here's my divisor. The first number would go inside, my divisor would wait at the door. This means 3 and 5/10 divided by 5/10, just like this. All right, let's go over to D. Set up my division. First number is my dividend. It goes in the den. And this is my divisor at the door. And something else that I do, this 0 whole number, I'm going to do away with that. I don't need it. I do have to have this 0 because it's in between a decimal and a number. So I'll keep that. Now, remember, here's my divisor. It's the boss. I want this to be a whole number. I can't divide with a decimal outside. How many jumps will this decimal have to make to make it here? 1, 2. So if this one moved 2, then this one moved 2. And by the way, if it was 2 jumps, remember if we did 1 jump, that's multiplying the number by 10. If we did 2 jumps, that's multiplying this number by 100. So now this one has to do 2 jumps. This one has to do what this one does. 1, 2. Bring my decimal up like we normally would. And now divide 5 into 350. 5 won't go into 3. 5 will go into 35 7 times. 7 times 5 is 35. Subtract 0. Bring down a 0. 5 into 0. 0 times 5 is 0. Subtract 0. So this answer is 70. Okay? Let's look at this one. First number goes in. This number, I'll get rid of that 0 whole number. Now, what I recommend for you to do is to pause the video and you try it on your own and then play it and see if you do it the way I do it. I want this 7 to be a whole number. To make it a whole number, this decimal must jump 1 jump. So this decimal has to jump 1 jump. And 1 jump, that means I multiplied each one of these numbers by 10. 7 will go into 42 6 times. 6 times 7 is 42. Subtract 0. So my answer is 6. Okay, hopefully you're starting to get the hang of it. This is not really hard. We're dividing the regular way. The only thing I'm doing differently is I'm moving a decimal. All right.
Anderson, come to the office to go home.
So let's turn over to page 308. I apologize for the announcements. I can't do anything about that. I'm just going to have to press on. Hopefully they won't interrupt us too much. All right, these will be done the same way. I'll work a few of them with you, and then you can go back and work the rest on your own. Okay? All right, let's start with G. Set up my division. First number goes in. It's my dividend. And this is my divisor. I'll get rid of that whole number. Now, I want this to be a whole number. Excuse me, I didn't say. I'll get rid of that 0 whole number because I don't need it. This decimal must jump one jump here. That means I just multiplied this by 10 to make it a whole number. So this one has to be multiplied by 10. So that means it'll do one jump. Bring it up. Now we're going to divide 9 into 108. 9 won't go into 1, but it will go into 10 one time. 1 times 9 is 9. Subtract 1. Bring down the 8. 9 will go into 18. 2 times 9 is 18. Subtract 0. The answer is 12. Okay, let's come down to I. We'll set it up. First number will go in. Remember, my divisor's the boss. However many jumps it takes for this to be a whole number, that's how many jumps you take over here. One over here. So this jumps 1. Now, you might be asking me, will this always go to the end of this number? No, it won't. You will see in a few minutes where this decimal won't always be at the end of the number. This one will always go to the end, but this one will not. Now I'm dividing 12 into 36. 12 will go into 36 3 times. 3 times 12 is 36. Subtract 0. All right, let's go to J. Oh, actually, I'm going to leave J open for you to do later. Let's come on to K. I don't want to make this video too terribly long for you to have to watch. You're probably catching on pretty well. 17 and 5/10 and 2 and 5/10. Okay, here's my divisor. It's the boss. I want this to be a whole number. For this to be a whole number, the decimal must jump back here. So it jumped one jump. So this one can only jump one jump. And now I'm dividing 25 into 175. When I'm ever dividing by 25 or using 25, I like to think of quarters. Now we know if I've got 2 quarters, I've got 50 cents, right? And if I've got 3 quarters, I've got 75 cents. If I've got 4 quarters, I've got $1. So here's $1. There's 100. If I've got 5 quarters, I've got $1.25. If I've got 6 quarters, I've got $1.50. And if I've got 7 quarters, I've got $1.75. So 25, it won't go into 1. It won't go into 17, but it will go into 175 7 times. And 7 times 25 is 175. Subtract 0. All right, let's move on down to number 2. 15 divided by 3 equals 5. Explain why it is true that 1 5/10 divided by 3/10 and 1500 divided by 300 have the same quotient. Why would these all equal the exact same thing? The reason is the ratio is the same. That's the proportion. Here we've got 1s divided by 1s. Here, tenths divided by tenths, and hundredths divided by hundredths. We're dealing with the same, you see the same digits, but because the ratio is the same in each one, we're going to get the same quotient. So if this equals 5, then this will equal 5, and this will equal 5. Okay, let's move on. That was page 308. Now we're moving over to page 309. 309. All right, it says Mr. Volek buys 2 4/10 kilograms of sugar for his bakery. He pours 2/10 kilograms of sugar into separate bags. So he is separating this into groups. And he's putting 2/10 of this into separate bags. 2/10 of it, 2/10 in another bag, 2/10 in another bag, 2/10 in another bag, until he runs out of sugar. How many bags of sugar can he make? We want to know how many 2/10 are in 2 4/10. So what's getting shared is all of this sugar. So I'm going to write that first. 2 4/10 divided by 2/10. So let me set that up. The first number goes in. And I'm going to get rid of that 0 right there. Okay? Now, I want this to be a whole number. So I want one jump, right? That means I just multiplied this by 10. So this gets one jump. So now I'm dividing 2 into 24. And it will give me the answer for this. I'm making the number friendlier to work with. 2 will go into 2 one time. 1 times 2 is 2. Subtract 0. Bring down a 4. 2 will go into 4 2 times. 2 times 2 is 4. Subtract 0. So there's my answer, 12. Oh, and I didn't bring my decimal up. So my answer is 12 bags. 12 bags. Now it says if he pours 4/10 kilograms of sugar. So now he's pouring it into bigger groups. How many bags of sugar can he make now? He's got the same amount. And now he's dividing it into groups of this size. And see, the group size is getting bigger, so he won't need as many bags because he's able to pour more in a bag. So I'll get rid of that. Set it up. First number goes in. Okay, one jump, right? So this one's one jump because I just multiplied both by 10. Now I'm dividing 4 into 24. And we know 4 will go into 24 6 times, and that is 24 with no remainder. So now we only need 6 bags because we're putting more bundles of sugar in the bag, or a bigger amount of sugar, excuse me. All right, let's go to number 4. 2 wires. One wire is this many meters long, and one is this many meters long. They were cut into pieces that are 3/10 meters long. How many such pieces can be made from both wires? Well, what I want to do first is, since it's 2 wires and I'm dividing these numbers to see how many 3/10 I can get out of them, let me go ahead and combine these numbers. Let me add these together. 17 4/10 plus 7 5/10. Bring my decimal down. 4 plus 5 is 9. 7 plus 7 is 14. Carry my 1. 24 9/10 meters. That's my combined measure for both the wires. Now, what do they want to do with these wires? Now that I've got it together, they want me to cut it into 3/10. They want me to share it into groups that are 3/10 meters long. And then they want to know how many pieces, how many groups will I be able to make? So I'm going to take 24 9/10, and I'm going to divide it by 3/10. See how many 3/10 I can get out of this, and that'll tell me how many wires I'll have. So I'll set it up. First number goes in. I'm going to cross that out. I don't need that 0 whole number. Now, I want this 3 to be a whole number. Remember, you can't divide with a decimal outside. So I'll jump 1 space here, and this jumps 1 space. Now I'm ready to divide, just like normal. 3 will go into 2, it won't happen. 3 will go into 24. 8 times 3 times 8 is 24. Subtract 0, bring down a 9. 3 will go into 9, 3 times. 3 times 3 is 9, subtract 0. How many pieces could I make? 83 pieces. All right, moving down to number 5. Mr. Smith has 15 6/10 pounds of oranges to pack for shipment. He can ship 2 4/10 pounds of oranges in a large box. So he can get that in a large box, and 1 2/10 pounds in a small box. If he ships 5 large boxes, what is the minimum? Minimum, that means at least the least amount he can get, the minimum number of small boxes required to ship the rest of the oranges. Okay, I admit, this is kind of wordy. So we're going to take it in baby steps. Now it says he has 15 6/10 pounds of oranges to pack for shipment. He can ship 2 4/10 pounds of oranges in a large box. And 1 2/10 pounds in a small box. If he ships 5 large boxes, let's go right now and figure out what will he be able to get in 5 large boxes. Now it says he can ship 2 4/10 pounds of oranges in one large box. So let's take 2 4/10 and multiply that, because that's in one box. They want to know how many he can ship in 5. Let's see. 4 times 5, that's 20. 10, 11, 12. All right, and since I've got a decimal here, I'll move over one number. So he can ship 12 pounds. Now it's saying, what is the minimum number of small boxes required to ship the rest of the oranges? So these got shipped. So let's see what's left. I started with 15 6/10. Let me take away what got shipped. Remember to line your decimals. 6, that's 3. So I've got 3 6/10 left to ship. Now, what did it tell me I could do? These have to be for small boxes. What goes in a small box? 1 2/10 pounds. So I'm going to say 3 6/10, divide it by the size I want, and I'm going to see how many groups I can get. That'll tell me how many boxes I'll need. First number goes in. I want this to be a whole number, so it needs to go 1 jump. So this goes 1 jump. That means I just multiplied it by 10. So 12 will go into 36 3 times. 3 times 12 would be 36. Subtract 0. There's my answer. It would take 3 boxes. I would need 3 boxes to ship what's left. Okay, we are moving on to the next lesson, and hopefully it won't take us as long since you've already been introduced to the skill. I want you to turn in your Learn book to page 315. You'll have to turn a few pages. We're on page 315. And we're not doing everything this lesson tells us to do for the sake of time. Right now, we are just going to focus on dividing. That's all I want you to do is just divide. We're not even going to look at this. I'm going to come right down here and start with A. Let's set this up. Okay. All right, we've got 53 2/10. It's going inside. I'm going to get rid of that zero whole number and just put 4/10. Now my decimal will jump one time, right? Just like that. And this decimal will jump one time. That means I just multiply both of these by 10. And now just divide as I normally would. 4 will go into 5 one time. 1 times 4 is 4. Subtract 1, bring down a 3. 4 will go into 13. 3 times. 3 times 4 is 12. Subtract 1, bring down a 2. 4 will go into 12. 3 times. 3 times 4 is 12. Subtract 0. And there's my answer, 133. And they had a squiggly equals because it's estimating, but we're not estimating today. We're just dividing it. This one you do the same way. All right, let's come down. Same things happening here. We're just dividing. We're going to look at A right here. I'm going to set it up. First number goes in. Get rid of that zero whole number. How many jumps? 1, 2. So this one jumps 1, 2. If it had 2 jumps, that means I just multiplied both numbers by 100. Now, 3 will go into 9 3 times. 3 times 3 is 9. Subtract 0, bring down a 4. 3 will go into 4 one time. 1 times 3 is 3. Subtract 1, bring down the 2. 3 will go into 12. 4 times. 3 times 4 is 12. Subtract 0. And there's my answer, 314. You can come back and do these later on your own. I don't want to make this video too terribly long, so let's move on to the other side of page on 316. Let's look at what we've got left. And I'm going to let's carefully scribble that out right there. And you see these thought bubbles? Let's just don't worry about those right now. We are just going to do the algorithm right now. We'll set this up. The first number goes inside. And I'm going to get rid of that zero whole number. Now, I want this 3 to be a whole number. So I need to multiply it by 10 because I want the decimal to move one time. So this one moves one time. And then I'm just ready to go and divide, right? 3 will go into 4 one time. 1 times 3 is 3. Subtract 1, bring down my 6. 3 will go into 16. 5 times. 3 times 5 is 15. Subtract 1, bring down the 2. 3 will go into 12. 4 times. 3 times 4 is 12. Subtract 0. There's my answer, 154. All right, let's come over to B. First number goes in. I'll get rid of that zero whole number. Now, I want this decimal to be behind this 4. To do that, it's got to move 2 jumps. This one must move 2 jumps and bring it up. That means I just multiplied both of these by 100 if they move 2 jumps. Now you're just dividing 4 into 316. And that will give you the answer for this problem. All right, I'm not going to work this because it's basic division. Let's go to C. First number goes in. I'll get rid of that zero whole number. Now, watch this. This decimal needs to move one time, right? One jump. This decimal can only move one jump. Don't think it's going to the end. If this one moves 1, this one can only move 1. So it's going to go right there between the 3 and the 1, and then you bring that up. And now you're going to divide. 3 won't go into 2, but it'll go into 23. 7 times. 3 times 7 is 21. Subtract, that's 2. Bring down a 1. 3 are going to 21 7 times. 7 times 3 is 21. Subtract 0. So there's my answer, 7 7/10. All right, let's come look at this one. First number goes in. It's my dividend. Here's my divisor. Let me get rid of that 0 whole number. Now watch what happens here. This decimal needs to go behind the 24. So I need to do 2 jumps. 1, 2. So this one goes 2 jumps. 1. Now I need to go 2. Put it here. What am I going to put in this space? I hope you said a 0. We're going to fill in the space with a 0. Now let's bring that decimal up, and we're ready to divide. 24 into 1,560. 24 won't go into 1. It won't go into 15, but it will go into 156. If you come and do your 24 facts, 24 times 6 would be what you need, because that's 144. Subtract, that's 2, 1, bring down the 0. 24 into 120, you come and do the math. We know it's less than 6 times. So if I do 24, let me try times 5. There it is. So it'll go 5 times. 5 times 24 is 120. Subtract 0. So that answer is 65. And this answer was 7 7/10. Okay? I want you to go back and do this one on your own. Now, let's look at down here, number 4. The total distance of a race is 18 9/10 kilometers. That's the total distance. If volunteers set up a water station every 7/10 kilometer, that means every 7/10 kilometer they're going to put some water out. Go 7/10 more, put more water out. More water. Every 7/10 they're going to put water out, including one at the finish line. How many stations will they have? I want to know how many 7/10 are in 18 9/10. So since the distance is getting divided, I would say 18 9/10 divided by 7/10. Set it up. First number goes in. All right, we're going to do 1 jump here. So I'm going to do 1 jump here. Bring it up. 7 won't go into 1, but it'll go into 18 2 times. 2 times 7 is 14. Subtract 4. Bring down my 9. 7 are going to 49 7 times. 7 times 7 is 49. Subtract 0. So we would get 27 stations. B says, if volunteers set up a first aid station every 9/10 kilometers, including one at the finish line, how many stations will they have? You do it the same way. You're taking 18 9/10 kilometers and you're dividing it now by 9/10. I want to know how many 9/10 I'll get out of here. That tells me how many first aid stations we'll have. So you would set that up and solve. First number goes in. Now, let's do the last one. In a laboratory, a technician combines a salt solution contained in 27 test tubes. Test tubes are like things in science. They look like little glass tubes. So we know we've got 27 test tubes. Each tube contains 600 liters of solution. If he divides the total amount in the test tubes that hold 3/10 liter each, how many test tubes will he need? Well, let's find out how much solution he has, or how much. It says he's got 27 test tubes, and each test tube has this much in it. So let's do 27 times, I'm going to get rid of that zero whole number, decimal 06. This will tell us how much liquid he has in all, the total. That's 42, 12, 13, 14, 15, 16. I'm going to stop here with my multiplying, because if I multiply 0 times everything, I'm just going to get zeros. It's not going to change this if I add. So here's my total. So I need to move my decimal 2 places, right? Which I don't want to confuse you. So let me add my placeholder. 0 times 7 is 0. 0 times 2 is 0. See, if I add that up, still going to get the same thing. But my decimal must move 2 jumps. Remember, when we multiply decimals, we count the numbers behind a decimal. 1, 2. So here's how many liters we have in all. 1 in 6,200 liters in all. Now, I want to take that and divide it out into test tubes that hold 3/10 of a liter. I want to know how many test tubes I'll need. I'm going to take this, 1 in 6,200, and divide it into groups that are 3/10. First number goes in. Get rid of that whole number. That 0 whole number. All right, 1 jump here means I multiplied it times 10. 1 jump here. Bring it up. 3 won't go into 1, but it'll go into 16. 5 times. 3 times 5 is 15. Subtract 1. Bring down my 2. Now we've got 3 into 12. 4 times. 4 times 3 is 12. Subtract 0. So it looks like I need 5 4/10 test tubes, right? And you can't really have 5 in a piece of a test tube. So I guess I'd wind up needing 6 test tubes, wouldn't I? 1 tube just won't have as much. Okay. I hope you understand this lesson. What I want you to do is go back and work the ones we skipped. On 316, circle B. I want you to do B. And I want you to do B here. Do these 2. And if you're at home working, take pictures and send it to me of the whole page when you finish. All right, turn back. On 315, circle B and B. I want you to divide these. Take a picture of this page and send it to me. And then, let's see. Then on page 308, you're going to go do H, J, and L. Take a picture of that, send it to me. Let me know if you have any questions.